Iain Young, thank you very much for joining us this evening for the final evening with of 2023. Um, I'd like to start by asking you a quick question, in which would probably something you would allude to anyway, but I think will probably interesting to many of the viewers tonight. In what brought you into lost wax casting and into brass casting and nickel silver casting?
Okay. I know Ian wanted me to chat about how I got into it. I actually got into it because I wanted to produce a kit. I got a chap to do a design for me, but I didn't want white metal castings. I wanted brass castings, and I didn't really want to go to Birmingham to get my castings done when I lived in the north of England. So I found a place in Newcastle. It was a jewelry repair place. Went to visit them. A year later, no castings had been done for me. Went to visit them again. He said, "Look, we're opening our own retail place, so we won't be able to do any casting." And I said, "Oh, what are you going to do with your equipment?" And he said, "Well, I'll probably sell it." I said, "How much?" He told me the price. I said, "Right, I'll buy it. Give me a bit of training and we'll go from there," which is basically what he did. I, at that point, had just been made redundant. Or I was in the process of being made redundant from a job. So I thought, well, okay, I'll start perhaps doing a bit of this. How I didn't kill myself in the first few months is beyond me, because at that time I had uh, what we referred to as a motorized centrifuge. Modern equipment uses all kinds of electronics in it, but this was a motorized centrifuge. You had to use a gas torch, which was oxygen and acetylene. So if you picture a burner's torch, it would be a burner's torch with a nice big long flame. And at the same time as you're trying to melt metal in a crucible, you're also trying to get the flask that you're casting into out of the kiln and put it onto the cradle in the machine. And trying to do this in a wooden shed is not necessarily recommended when your flame is like 2 foot long. And that's how I started. So really, the beginning for me was, it was going to be a little bit of a hobby. It would have allowed me to produce my own kits, all the parts for my own kits, and then as a result of being made redundant, I had to turn that into a manufacturing process. And although the centrifuge was a machine for manufacturing in quantity used in the jewelry industry, it was really designed so you'd have two people doing the job. So I needed to get a more up-to-date machine, and I purchased still a centrifuge, but it was an induction melting, which uses alternating magnetic field to make the molecules of the graphite crucible rub together to create the heat in the crucible, which melts the metal. And that way you don't have to have a second hand. You can get things out of the kiln on your own, put into the cradle, close the lid, lower the coil, the arm spins, and the metal flows into the nooks and crannies. Since that date, I've stepped up the ladder, and I now have a vacuum-assisted casting machine, which tends to be the norm in most jewelry casting shops these days. There is more advanced equipment, but the chances of purchasing that and actually paying for it are limited. So I got into it by accident, and I've just learned from there, picking other people's brains, experimenting, and got to the point that I'm at now, producing castings for various different manufacturers and for myself, and for individuals. I do get individuals who say, "Oh, I only want to make one axle box. How can I turn them into 6 axle boxes?" And this is an ideal way of doing it. Right, so that's just my little history of how I got into the game. That's 30 odd something years ago, and it has fascinated me ever since. if you really get me chatting over a cuppa, I'm almost like a big kid. I can't resist it. It's just so exciting because you don't know that the castings are going to come out until you actually quench the can and get the plaster off. I did a load of casting yesterday, and one of the cans I'd obviously messed up when I was putting the investment in, and I'd lost a load of castings down one side. So even after all this time, still make mistakes, but it just thrills me. I love doing it. And hopefully a little bit of my excitement and enthusiasm for the process will come out during my short presentation. I'd like to make one little point about the fact that although I love lost wax casting, I don't think lost wax casting is the be all and end all for model railways. We use a lot of different media in model railways: white metal, etching, 3D printing, resin casting, plastic injection molding, and lost wax, etc. And all of those media have a place in what we do. Some people will come to me and say, I want to do every casting in lost wax. And I'll often say, but you don't need to. And it sounds like I'm taking food out my own mouth or off my own table, but you have to weigh up. If you're producing something and you're going to sell it, you've got to control your costs. And hopefully my advice helps people when they come and talk to me about the process. So I want to go on and just give a wee potted history of lost wax casting. Lost wax casting goes back to the ancient Egyptian days. So it's been around an awful long time, although there weren't obviously railways in ancient Egyptian times. Our first experiences here of lost wax castings will probably have been on what we often refer to as Jap brass locomotives, the likes of products from Tenshodo or Sam Hongse. Then the United States were using lost wax long before us. Precision scale in America, one of the earlier manufacturers to produce separate castings available for modelers. In this country, I think one of the earliest ones, many of you will know his company, but he was John McWilliam. He traded as Hobby Horse Developments. He had his castings done in America originally. He was very early days. And then the earliest that I know of, apart from him, was a chap called Malcolm Stelfox. Again, if any of you have been 4mm scale modelers, you would probably have known of Stelfox products. If you purchased brass castings from W&H, those who remember that little catalogue that used to come that we used to drool over, W&H had a range of lost wax castings. They were actually produced for W&H by Malcolm Stelfox in Norwich. And then perhaps going on from there, the next one that I would probably know of before it became kind of mainstream was a chap called Stuart Black. He traded as Micro Metal Smiths. Some of you may be aware of the J39, the LNR J39 that he did. He did a lot of, he used a lot of lost wax casting. Very, very talented, clever man. I didn't know him personally, but some of the stuff that he did in his day was brilliant. So, and after that, it started to get more mainstream. The likes of Slater's producing lost wax castings, and Alan Gibson did a range of separate lost wax castings, and so it has gone on from there. The metals that when I talk about lost wax casting, I'll be talking about basically the things that I do personally. I can't necessarily speak for other casters. There are various other casters out there. Some are good, some are very good, some are poor, and various stages in between. The metals that I cast with are various brasses. I cast in copper, nickel, silver, bronze, gunmetal, and each of those are for specific purposes. Brass is the most common one that we see. Nickel silver we use obviously for the parts that represented as steel or unpainted steel on a model. Copper or 95.5 phosphor bronze would be used for your copper cap chimneys. One manufacturer I do pipe work for which uses copper. Then bronze and gunmetal, more used in live steam, less likely to have corrosion issues with live steam in there. But all of these metals are copper-based alloys, and there are hundreds of them, absolutely hundreds of them that are produced for different purposes. But I use a select few. The actual casting process itself is either these days is either centrifugal or vacuum assisted gravity casting. Hand pouring gravity casting using risers is mainly used for ornamental and statue castings. Although I do have a half-built model that I'm on with, or I've been on with for a few years, which was manufactured in France, and the castings for that model were done in an art casting shop using that gravity and riser process. The castings are beautiful, but it's not an ideal way to produce things for our purposes. So those things are just for interest. We're now getting onto the subjects that you probably want to know more about. I'm going to talk about moulds and shrinkages. Most casters up until a few years ago would have used what's referred to as natural rubber for their moulds. This rubber, if you've seen white metal molds, they generally use a black rubber, but you take your pattern and you put it into a frame and put rubber within rubber, and it goes into a vulcanizing press, and using heat and pressure, the rubber is vulcanized around the master. And the master in this case would have to be metal. I started off using that. In fact, what I've done is I brought 3 of my very earliest molds with me. These go back to when I first started. I did these for a chap in Scotland. So I don't know how easy it is for you to see that.
Yeah, we can see that. Okay.
Okay. Yeah. So what we've got here is a wax within a mold for a smoke box door. That's for a Caledonian locomotive in 4mm scale. That's one of my very first molds. Jim Smiley of Cali Coaches, bless him, was pretty much my very first customer. And we have another one here of a dome. Oh, sorry, not a dome, chimney. Slightly different rubber, basically the same. But these are vulcanized molds. They use heat and pressure to be created. What I found, though, is by using vulcanized molds, they are very durable. They last for years. Generally speaking, you never have to replace the mold. Is that they don't shrink in a linear manner. So often your dome, if you have a dome, for example, it won't come out round. It'll come out slightly oval because the shrinkage in thickness is different from end and width using the vulcanized process. Or that's the experience that I've had with it. The likes of Adrian Swain in the past used to make oval patterns so that he could make his molds so that his domes would come out round. Oh, that's what he told me. He could have been having me on. He had quite a dry sense of humor at times, did Adrian. Also, I found the shrinkage with natural molds can be quite high, around 4%, which is quite a lot. So I started many years ago, 20 odd years ago, experimenting with various different silicone rubbers. I never went through the process of using heat vulcanized silicone. I went straight to the room temperature vulcanizing. We refer to them as RTVs. Tried different ones, and eventually just went totally across to using silicone rubbers for molds. The shrinkage in a silicone rubber, around about 1% for brass. Nickel silver, which the shrinkage can be about 2%, but that's about where you want to be. If you were making a pattern and you wanted to actually have exact dimensions, that 1% for brass, 2% for nickel silver would probably be quite adequate. Right. Sorry, I was just looking at the notes at the side of this. Malcolm Stelfox is still around, bless him. That's really nice to know. Sorry. I'm sorry, I'm going back to my notes. Silicone rubber is usually a two-part mix. There are two types of silicone rubbers that are used for molds. One is a tin-based cure, and the other one is a platinum-based cure. The platinum-based cure rubbers are much more expensive, but are much more durable, much better rubbers generally all round. But if one has been using tin-based cure rubber, the platinum-based rubber will not cure against anything that has been in a tin-based cured mold. So we have to be a thorough cleaning up. And I'm going to touch on cleaning up patterns that have been through. Well, I might as well do it now. I've got it. Natural rubbers. We looked at the natural rubber. Actually, this is a Malcolm Stelfox mold here from early days. That's for a Great Eastern Sharp Stewart. But natural rubber, if a pattern has been used in a natural rubber mold, the platinum-based silicone rubbers will not set against the pattern. When you cut the mold open, you get inside of it, it'll all be just gummy around the pattern, which is not ideal. I found out by accident. I used to use an old mold as a guide when I was spruing patterns up for people for fit in the mold, and I was finding that the molds, the stuff wasn't setting, and it was because I'd been resting them on a natural rubber mold as a guide. And so there are various things that inhibit the cure of the silicone rubber. So it's vital to make sure patterns are cleaned up. If it's been in a white metal mold, it's a nightmare to clean up the patterns properly. And I usually end up, after doing a thorough clean, of giving a light coat of primer before I make a mold. Certainly if it's been through a white metal process, it's necessary. So there we go. Silicon's shrinkage. We've done that. I've talked about the fact that the natural rubbers don't shrink in a linear manner. If you use a jewelry caster, Birmingham, for example, you might want to talk to them about the shrinkages that they recommend. Okay, I can only, again, for my purposes, I can only speak for what I do. Materials for patterns, almost anything can be used. If the mold's going to be made in RTV, from an RTV, a silicone mold, almost anything can be used to make your masters, as long as it's not porous. Because obviously, if you were using wood, for example, the mold would be vacuumed at some point or other, and it would soak into the wood, and you wouldn't get a good mold. So that would have to be sealed. If you do use wood, which is doubtful, it would have to be sealed. But you can use plastic, metal, almost anything can be used to make a pattern. So there's no concerns for you there. Vulcanized molds, the patterns will always have to be metal. And although you can use soft solder, I don't recommend using low melt soft solders like you would use for white metal soldering. I would say a minimum of 145, preferably a higher melting point solder for making your patterns. Otherwise, they could come apart in the mold. They often do come apart in the mold when they're being vulcanized. But sometimes, quite regularly, you get away with the fact that it makes the mold, and then when you cut the mold open, the part falls apart, but it hasn't moved. But it can. So it's advisable to use a higher melting point solder where possible. If you can hard solder, if you can silver solder, so much the better. Because then, of course, you don't have any issues at all. In the jewelry industry, the patterns would probably be rhodium or gold plated before the mold is made. Again, going back, trying to think of one of these molds, doesn't really show particularly well, but the rubber can react with the metal, hence the discoloration of the pattern sometimes, but it also will give a matte finish in the mold. So in the jewelry industry, what they would do is they would nickel, then gold or platinum or rhodium plate, and that doesn't react with the rubber. So they would get a really nice, smooth, clean finish in the mold. And that way the waxes will come out easier. You don't have to keep on dusting with talcum powder or spraying with a silicone release agent to get the waxes out, because the finish is much better. But in our case, we would often send it to a caster, and they would do a vulcanized mold. The mold will be a matte finish, and it's just harder to get the waxes out of the mold because the wax tends to cling to the matte finish in the mold. Where are we? And I just said here that it's worth having a caster who is knowledgeable about model railways, as they can picture what you want and they can advise you with regard to anything about making patterns and sprueing, etc. In one of the very early MRJs, and I think it's an issue in single figures number wise. There was a nice article on lost wax casting by a chap. Didn't use me. I wasn't doing. I hadn't publicised myself then. He used a caster from Birmingham, a chap called Terry Byron, very nice man. I mean, the company, he's retired and the company's gone now. But the article's useful to read. It's worth seeking it out if you can. And if you go onto YouTube, there's bucket loads of videos on various different ways the lost wax casting is done. Probably little showing model castings, but plenty showing jewelry, and the techniques are almost identical. The mold cutting is the difference. And talking of which, unlike jewelry, we as modelers want sharp details, and we often need, not only want, but we need the parts to remain square, to not distort, etc. And to achieve this, we can't rely on the flexibility of the rubber mold alone. Sometimes we have to make removable cores or even removable sections of the mold itself. Now, I'll just show you one of these earlier molds that I used, this one for Cali coaches for a chimney. In the jewelry industry, you tend to flex the mold, and I'm trying to see. Can you see that?
Yep.
Flexing the mold, and then you're trying to lift out the wax. And if you can see the wax there of the chip. Okay, so you're relying on the flexibility and sometimes the cutting of the mold to get the wax out. Now, what I've done is let me just put these oddball molds out of the way. If you hear some notes, that's the piano. Right. Now, what I've done is I brought 4 molds along with me. I'm hoping that the waxes in these molds have still got a bit of flexibility, because they can go brittle when they've been sat around for a while. And this is for a Great Western pony truck. and it shows some of the techniques that I use. These are quite early molds from the silicon point of view. I'm realizing I've got to try and hold these up. So open one half. This is for the bolster. We can see the bolster there. And then this is just a normal standard run-of-the-mill mold. Flex it a little bit. Out comes the wax for the bolster. And a couple of other parts. That's one part of the pony truck. Then we go on to, and this just shows some of the techniques of using core plugs. This is another one. This is for one of the side frame parts of it. And we see that?
Yeah.
Okay. And you'll just see here, oh, wrong side. On this side here, you can see a piece of wire. Now, that piece of wire allows us to have holes. I see again, I don't know if you can see that, but by taking the wire out, we've got, and I can't get it.
Well, it probably won't focus that
sure.
closely.
But it allow us to have holes through that can aid assembly of various parts. So that's using wire for core plugs.
Iain, can I just quickly interject? Arthur has said, I think people like Shapeways can take a 3D drawing and make a wax master from this.
They can.
Have you any experience of these as well?
Right. Now you've just interrupted me halfway through.
Sorry, mate. Sorry.
No, it's okay. No, it's all right. That's fine. Right. Shapeways produce 3D prints and using various different items of equipment, some of which are better than others. And some of those machines can print in a material that will burn out in the casting process. I have tried burning out normal resin and 3D printed resin, and there's always a residue. You don't get a good casting. And some of them expand in the kiln and they crack the plaster, and so you end up with flash. So they've developed these materials that can be burnt out, and they work. Some of them work very well. The best of them is manufactured by a company called Solidscape, and they print. They're basically, if you think of an inkjet printer, it's printing dots of two materials. They're both a form of wax. One is the wax for the pattern, and one is a wax that supports the pattern, is a support material. And when it's printed, so it's printing like an inkjet printer, but then it's also printing layers on top of itself. When it's finished, what you get is a two-colored lump of wax that goes into a bath of warm mineral oil, and the support wax, which melts at a lower temperature, that melts away, which leaves you with a wax print of your original. That then can go into the lost wax process, be cast and used as a master, or used as the part for the model or the piece of jewelry. The quality is phenomenal, but the cost of the machines matches. The 3D printing machines that we see that have little supports all around them, they also have various waxes or materials that can be printed and used by burning out. So the basic answer is yes, they work. They're very good. The quality these days, the quality is just phenomenal, regardless. I like the stuff from the Solidscape machines, probably because they are exceptionally good. You can do the lettering on the axle boxes, and you can read it all. But the prints are expensive because the machines are expensive, and it's much more time consuming than the 3D printers that we can buy. I was going to say buy from China, like the Elegoo frozen machines, and I'm going to touch on those again. Does that answer the question?
I think it does. Yes, I mean,
okay.
Arthur was asking.
If you want to ask any more, by all means, interject. I just want to go on to the next mode would be a repeat of that so we you know, one was a left-hand side frame, this one with the right-hand side frame. So I won't open that one. This one takes us on to showing another part of the process. This is the what I would call the A-frame. So we've got the frame there. Now, to get this one out of the mold is, I just want to show it because it's quite important. Be careful to take these out. This is quite an important part. But you notice it comes out with two pieces of rubber. That way, I can take them out sideways. And then we have a nice square item that's not distorted. And then, of course, the pieces of rubber can go back into the mold. So that then allows one to cast the parts in brass, and then they can be assembled into a lovely square Great Western pony truck. This one's for a 44, 45. I'm not a Great Western man, so I apologize if I make any cock-ups in. But there's also a larger one for the bigger Great Western locos. And I'd like to thank Warren Shepherd for allowing me to show you these parts. He does both of these trucks, and I've got to say they really are nice. So that kind of shows core plugs, and it shows removable sections of rubber in the molds. And the molds can get quite complicated. I'm just trying to think. This one's from my river kit, Great Western River kit, and these are the splasher extensions that you see below the foot plate. So again, I've removed that with the rubber, and you would peel the rubber off there and there, and so we don't get the distortion, and then they can be used nicely on the model. So it's using the actual material in a different way to serve the purpose that we have. In the jewelry industry, generally speaking, they rely more on flexibility, but I've got to say some of the jewelry molds for making hollow rings, etc., is very clever, and I've never succeeded at doing that. So you know, the talents that are available in the jewelry industry are just a bit different from what we would use for what we need. And then one more, if you don't mind me showing you it. And this one is a little bit different. You see this mold, take this mold open. We have a nice core plug in there, and also removable sections. And so this one comes out of the mold there. Remove the removable sections, put them back into the mold, slide off the core plug, and we have a crank axle for inside motion. That's for Stephenson's motion. I don't know if that doesn't seem to be focused on my screen. So
no, it's fine. We can make it out here. It's fine.
Okay, that's all right.
Yeah.
Right. So hopefully that's just gives you an idea of the ingenuity that can be used in the process that we have. I've got one or two more molds I'll show as I'm going along. Can I get?
Iain,
Yes.
while you just described there, obviously some molds, and you mentioned core plugs.
Yeah.
Ian McCormack has said Mike Trice with white metal castings
Yeah.
uses PTFE stock for cores.
Well,
Could that be used for this also?
Yeah.
And this is what he's going to lead right onto. Yeah.
I'm going to show you molds using PTFE cores. PTFE cores are great because you can use them in white metal, use them in the lost wax process as well. Obviously, you can't cast metal around PTFE, but you can cast. You're injecting the wax around the PTFE, and it's a nice material for using for cores, and I do use that myself. I'm just coming on from there. So we've done that one. Now, mentioning the pony truck, in theory, it would be possible to make a mold to cast the pony truck in one piece. But one, the mold would be so complicated, it would be difficult to get the wax, even to get the wax out straight. But also, it would, from a financial point of view, one would probably end up producing 4 or 5 waxes and get one decent one each time. So sometimes it's better to use sub-assemblies to create what you want to do rather than trying to be too clever. I mean, I think I'm quite clever at making molds, but I know there's a limitation on what one should do as opposed to what one can do. And I'm going to show you something in a second that was what I call my eyes bigger than my belly syndrome. So right now then, you talked about the chimneys. I'm just trying to find said chimney. We've got 2 here. This mold, silicon mold, and got a chimney in it. And to make sure the chimney's hollow, we've got it doesn't want to come out, which is typical. We have a PTFE core plug. Doesn't have to be PTFE, it could be metal, but in this case it's PTFE. So that's one, and I'll show you a second one. Now that one only went part of the way through the chimney, as is this one, and this one will take us on to another aspect. And I'm hoping you're going to be able to see this on, but this one might not be so easy to get. Oh, isn't it? The nice thing about PTFE, it seems to be almost self-lubricating. And so the core plug, PTFE core plugs, will tend to come out of the molds much easier than metal ones. Even when the metal ones are polished, the PTFE seems to just be that little bit better. But we're going to come back to this chimney in a moment because it shows a defect. Right, yes, okay. Now then, I have a diagram. I'm going to talk about chimneys and making patterns and core plugs. Now, our chimney looks reasonably nice, but you might be able to see at the base of that chimney, just where it goes to just go into the flare, it necks slightly. Do you understand what I mean when I say necking?
Yeah.
So it's pulled in slightly, and that's due to the mass of the wax there. As it's cooling, it can pull. Now, as it happens, in the case of that chimney, the pattern was a bit like that, so that didn't help. So that core plug, although it goes all the way almost down to the base, it there's just enough mass there that when the wax cools, it pulls the necking in. And what I've done is a terribly coarse diagram so that you can actually see the effect that I'm talking about. And we've all probably seen it at some point or other. So to make it work better, let me find another. This is a different one. This is the chimney for the Great Western River, and we'll take this out of here. And you'll notice I've come out with a big old lump of rubber, but that big old lump of rubber goes all the way through.
Right.
Okay. And that way we alleviate the necking issue. Obviously, you don't have anything for location necessarily, but that will produce a far better finished part. In fact, this is a copper chimney, so not quite a river one. It's still a Great Western, I'm sorry to say, but it's done in exactly the same manner. Although this one had a metal core in it. Okay, right now then, we've seen that. River chimney. Now, heavy castings, where possible, it's better to hollow them out. Again, we've got some very coarse diagrams. Items that have flat surfaces on them display the issue. So sandboxes are a prime example of this. So we have here a very basic looking sandbox. Yeah.
Yeah.
Many of you will have seen this effect on
Yeah.
their boxes, where
Yeah.
it's sunk in the middle, because when the wax is cooling, if it hasn't got a reservoir of wax to draw upon, it will cool on itself and it will pull in from the sides. Okay, and so you'll get this sinkage effect. So the way around it, going back to this picture here, is to make the pattern hollow. And in this case, we've got a plug. Okay, can we see that?
Yeah.
Okay, and that would alleviate this problem by having it hollow. You're reducing the effect of the contraction of the wax. And we have a mold to show it, I think.
Hey.
He's trying to stay ahead of himself. I'm sorry again, this one's Great Western. I don't know why it's been Great Western molds that I've grabbed hold of today, but we've got a sandbox on there, again for the river, and this one has a removable piece of rubber, and we pull it out. There we
Yeah.
have a plug, and we have a nice hollow wax, which gives us a lovely hollow brass casting.
Lovely.
Okay, right. I've got to tidy this lot up when I'm
I was
finished.
going to say you need to tidy it all up and put it. Take it back tomorrow.
I'm making a right mess at one side of me, but if it helps. And then where's the other? Oh, I've got one more mold now. This is quite important. Domes are horrible. When I say they're horrible, they're not really horrible, but a lot of in the past, I don't get it so much now. I do in 4 mil, but in 7 mil, I don't get it as much as I used to. Someone would send me a dome, and it would be a solid dome.
Yeah.
And to cast the bigger items like that, all of the other temperatures that you're using, the temperatures of the flask that you're casting into, on the mold that you're casting into, the temperature of the metal that you're casting are different. And so you have to wait. Sometimes you've got to wait 2-3 hours before the flasks are at the right temperature to do the heavy stuff, because you've already done the fine stuff first. So ideally, domes should be hollow. And again, I've got another mold here with a dome. And I'm sorry to say, this is also a river dome, Great Western.
Is this because you're plugging the kit, Ian? Yeah.
No,
Are you sure?
when I took over the river kit, a lot of the fittings weren't very good. I was going to use stronger words, but weren't very good. So I had a lot of new patterns made. So these are fairly recent molds, and so they were ideal for showing the process. And so in the case of the dome, we have a removable plug of rubber, and they have a nice hollow dome. But I'll just break this with quite a thin, I don't know if we can see it there, wall on it. Okay, and that will give a lovely finish on the brass, and that will polish beautifully for your model. Okay, so it's a personal thing, but I like that a lot. So hopefully that's useful. Right.
Ian,
Yeah.
Bob asks, how are the separate core plugs produced?
Well, when you say the separate core plugs, we're obviously not talking about the rubber core plugs. You actually I actually cut. Well, use the dome for example. When I cut a mold open, I'm using a scalpel. You can see all the zigzag effect around the edge from the scalpeling for the location. When it comes to this part, I would flex the mold and be cutting underneath until eventually that comes away. So it looks higgledy-piggledy because it is, but you're trying, again, you won't be able to see it in the mold too well, but you're trying to make sure your cut is around the skirt at the right place.
Yeah.
And the other nice thing about doing a mold this way, you notice that I've sprued it to the nearer the top of the dome. That helps the wax to flow into the skirt and allows you to have a thinner skirt flare on it. Because when you look at a real locomotive, it's not like tripping over
A brick.
a brick.
Yeah.
It wants to be quite fine, and we can get it reasonably fine by doing it that way, which means, yes, you do have to clean up the sprue here, but I'd rather clean the sprue up at the top end than try and clean off at the skirt and get it right. But that's just a personal modeling thing.
Hopefully that answers the question for you, Bob. Yes, he says thank you. Dave Smith has a question. Dave, if you'd like
Go
to
for it.
answer that.
Yeah, it's watching you handling those waxes, Ian. They seem to stand up to quite a bit of rough handling. The way you were tugging those cores out, I'm guessing it's a special type of hard wax, is it, that you use?
Well, it's an injection wax, and there are various different waxes for different purposes. I had one customer who wanted some very thin, long, thin, wiry items doing, and I couldn't get the wax to fill the mold. And eventually I had to do a lot of research about congealing of the waxes to track down a wax that would fill those particular types of molds. So it has a later congealing point. But as in the case of metals, and we'll touch on that, what you gain with one hand, you lose with another. And those waxes tend to be a bit more brittle, and they tend to cling to the rubber more. So there's a science to the waxes for different jobs. There's a French caster, brilliant caster called Benoit Sembla. Like me now, he has more than one wax. He uses different waxes for different purposes. So you could, in theory, get a wax that would fill a sandbox, and it'd be solid, and you wouldn't necessarily get that sinkage. But that would then tie up a whole machine for that. I use 3 different waxes in my different wax injectors for different purposes. But the jewelry waxes are very durable. They have a certain amount of what they would call memory. So it will spring back to shape on the whole, but that won't go back to shape now. But I'm having to put a fair amount of pressure on that, so it's not breaking. But if I left that in a tray for 2 or 3 days, then the wax would get a bit more brittle and would break easy. So I tend not to have spare waxes sitting in the wax trays. I tend to do enough for the job, perhaps an extra one, just in case I cock it up, which even after all these years of experience, I do on a regular basis. The waxes have got a certain, they all have different properties, just like the brasses have different properties for different jobs. So hopefully that answers that question.
Yeah, thanks, Ian. Yeah.
And go back to the core plugs, of course. I mean, obviously your PTFE ones, you turn cores, and your metal ones, you turn those in a lathe. But the rubber ones, it's how the mold is cut. Just talking very briefly about the quality of a finished casting. The quality of your casting will never be better than the pattern. The pattern is key. And then the next key item is the mold making. After that, it's almost just going through routine. But the quality of your finished casting will, on the whole, come down to the quality of the pattern and the quality of the mold. Right, now then. Right, yes. Okay, going back to another diagram. We have a diagram here. If you're making a pattern that has a hole in it, okay, the rubber will try and cling to the wax, or the wax will cling to the rubber. Now, obviously, this is an exaggeration. I'm talking about if you've got like a 0.3, 0.45, 0.7, 0.9 hole in there, it can cling. And my recommendation to people always is to just, and I know I've exaggerated it here, but you can see it there, just take the edge off that root, transforms it, because sometimes the wax will cling onto the piece of rubber, and the rubber will come away with the wax. It will tear at this root here. And so I always say, just take the edge off it, and that will make a huge difference to how things will work. Okay.
Right. Yeah.
Hopefully that makes a bit of sense. And while we're on the subject of blind holes, if you've got a long blind hole, and the example I've used for my very rough diagrams is a crosshead driven air pump. I see you them on earlier, Great Western Locos. King Arthur's had them at some point or other. So, I've mentioned this a locomotive. That's not Great Western. Sorry about that. But if you can picture that so your air pump would be a bit like that on one side. I've put a feed where I would put the feed onto it. Now I did one of these for Eric Underhill years ago when he did the Vulcan kits for a 1366, which has a crosshead driven pump on it, and it's blind at this end. Now what happens when the metal see, I've done it this way up. I can see it there. We've got the feed here, so the metal is going to go in there. Now, when the wax is melted out, effectively you have a hollow, and that is a column of plaster, gypsum plaster. So if you think of the plaster that's all over the walls in your house and the ceiling in your house, it's basically the same stuff with one or two binding agents in there, and it's ground to a finer consistency. That is basically going to be a column of plaster. And when the metal goes in, I know these are very rough. When the metal goes in, it sometimes fractures at the bottom and breaks, goes up the side, and you end up with a hole in the side of said pump. Okay, which is what I was having with Eric Underhill's over and over again. And I own that kit now. And I now, when I do the wax, it's a terrible thing because I do it for myself, but I wouldn't want to do it for customers because it's long-winded. I drill a hole in at the top now. So I drill a hole in the side here just so that it's supported at the top. And then when the metal goes in, it's not as big an issue. It's also not as big an issue now that I use vacuum casting as opposed to centrifugal. The centrifugal seems to fling the metal in there in a much more vicious manner. So another way for doing it would be a bit like this. Okay, so here we have the pump. No longer got a lid on it. The lid is on the side. There's a separate item. Plaster is supported both ends. Not a problem. Okay, and the thinner this gets, the smaller the diameter get, the more likely that is to happen. And if it's really small, I haven't put them on the market yet. I've shown them to people and they work. I've done some Great Western Station and yard lamps, and we've made them hollow. But because they're quite tall, even this didn't work. The metal would go in, it would fracture the plaster in the middle, and you'd end up with a hole in the side of the casting. So initially we tried making a mold by putting brass tube in, because we wanted hollow to put the LED through there. But in the process of melting out the wax, the temperature of the flask gets up to 750 odd degrees Celsius. The brass tube would soften, and when the metal went in, the tube would just bend and do exactly the same thing. So now we put stainless steel tube in there, and the metal can cast around it, and that works a treat. But like I say, the thinner it gets, the more that becomes an issue, particularly with blind holes. Right, okay, so I'm just on to the next bit. Right, and using cores again allows you to put holes into things. Now I've done a little diagram here. So this is a piece of wire in the mold, and these are like your brake hanger brackets off the frames.
Yeah,
that's your main sprue, right? A piece of wire is in the mold. the wax is injected into the mold around that piece of wire. Before the mold is opened up, you pull the piece of wire out, you open the mold, take the wax out, and you end up with a sprue of waxes which have holes all the way through them. Now, I've only done it on one side. I could have done it both sides, but it was just, you know, my lazy sketching. They're not to scale, by the way. Right, is that my last diagram? That's probably one of that's my last diagram. So we're safe there now. Okay, so where have I gone?
Probably trees next.
Oh no, I've lost all my notes. Ah, no, I have. Where am I? Oh, there we go. Right. Now then. Oh yes, one, and I show you a casting if I can. Now this is a sprue. You can see the sprue. On here you have a Great Western again, but it was a perfect example of a Great Western loco jack with the support and various other bits and pieces. But in the top of that, the little ball section has holes all the way through.
Yeah.
Do that again, you have wire in the mold. You can't rely on the rubber. The rubber would tear, break. So we have wire in the mold to allow us to have those hollow. So when you mount them on the foot plate, our little, what looks like a lamp bracket here, can then go and support that end of the loco jack. So we can do that kind of thing using wire as a core plug. Okay. And now then, gentlemen, I assume it's gentlemen. If there's any ladies there, I apologize. I'd like you to close your eyes just for a brief moment. I want you to picture your collection of various model railway kits, locos, whatever. And I want you to picture your, how can I say it? What was the word I used? I'm just trying to find my notes here. I want you to picture your eyes were bigger than your belly purchase. We all have one, at least one, of something, whether it's too big for the layout, too small for the layout, with the wrong railway or the wrong period, but you just couldn't resist. Yeah? Right. Well, I want you to open your eyes now, because I'm going to show you mine. I love lost wax casting. You can tell I get enthusiastic about it. But I wanted to do the boiler. You know, some of you know that I do a Ransoms and Rapier 36-ton crane.
Yeah.
And I wanted to do the boiler. And the boiler doesn't lend itself to being injected. It's very difficult to hold a big mold. So, in a moment of madness, I bought a machine that allowed me to pour wax, to heat and pour wax under vacuum. And this is the mold. All right. And this mold comes apart in different sections. Pulls out there. And then the center comes out. And then that splits. And you can you won't be able to focus on that, but you can kind of see the boiler shape there. All right. Now, that allows me to do the wax of the boiler with the detail on there.
Wow.
In one piece, which allows me to produce a brass boiler casting for said crane. Okay. Now, I've got to tell you, that machine cost me a mint and it will never pay for itself, but I love having it because I can play with it and I do use it now and then for certain jobs, but it was that thing, and we all have something like that, but that was mine, and I don't regret buying it, but from a financial point of view, it was never going to pay for itself, because the maximum number of those waxes I can do in a day is 2.
Right.
The mold has to be heated up to about 90 degrees Celsius before the wax is poured in, and then you have to wait for the whole thing to cool down so you can take the wax out, you can take that mold apart and take the wax out, and then go through the whole process again. And so I usually I get no more than 2 a day out when I'm doing these. I've just done a batch, and these are going into cast this week for a couple of customers. But yeah, that was my eyes bigger than the belly purchase. I just thought you might find that interesting. If nothing, I've done some weird and wonderful things on it for other people.
Can I have a quick word?
You can, yes.
Can you hear me?
I can.
Earlier you were saying that when you were using plugs in your moulds made of PTFE and other materials, that it wouldn't stand the casting metal on it. Only the wax.
Only the wax, yes.
But when I were white metal casting many years ago.
Yeah, white metal's different. I'm sorry,
I know
sorry to talk across here. It's a lower melting point.
Temperature.
Well,
I got hold of some material to make plugs out of, and I have a piece here. It's called Peak. PEEK.
Right. Oh, I haven't heard of it.
It's self-lubricating. It's a bit like PTFE, and I could put that in my white metal molds as a plug. Cast the buffers in particular. I had buffers that I could pull the plug out, and the double diameter were perfect for Slater's buffer heads without any drilling, messing about. And I just don't know whether you'd heard of it or not. I don't know what temperature it will go up to.
Well,
it certainly
I don't know what I don't know what the metal temperatures are for white metal, because white metal casting is a different black art to my black art. Okay.
Of course.
But the metal, if I'm casting, say, very fine parts, there's some pipes for M7 push-pull gear. If I was casting those, the metal would be going in about 1065 Celsius. And I don't, I can be certain that the PTFE wouldn't handle that. So the white metal, you can use PTFE with, and Peak. I don't know what that material is, but you can't do it with a lost wax just because of the sheer temperature of the metal. So you have to do it a different way, But no, it's a fair question. People in the past used to say, "Oh, you do white metal casting as well," and I always say it's a different black art, and it takes different skills, which I'd love to learn, but I'm still learning what I do now. I never stop learning. It just fascinates me to death, really. Right, can I go back to my notes?
Ian, just before you do, the Peak that Dougie mentioned is polyether ketone.
Right.
It melts at 640 degrees Fahrenheit, 660 degrees Fahrenheit.
Yeah, so that wouldn't handle molten materials at all. Yeah, but it would be ideal for plugs.
Yeah.
In the mold to inject the wax around. Okay. Right. So yeah. So you've seen my sledgehammer to crack a nut job. I'm going to talk about plastic. Particularly styrene can be used to make patterns from which molds can be made, or can be burned out like wax to create a brass part. If you're using styrene, styrene burns out beautifully. The cheaper the styrene, the better it seems. Some styrenes have filler in them, which will leave a residue in the mold once the wax is burnt out, but still seems to work well. I did a couple of Airfix cars for a jeweler a few 20 something odd years ago. One was a Bugatti, and we used the kit, burned out all the parts and cast them in silver, and he assembled it and polished it and patinaed it and sold it in his jewelry shop. That styrene burns out very cleanly. If you remember the Airfix soldiers, they're called the OOHO figures. They're in more of a polythene type material, bendy plastic. That doesn't burn out as cleanly as styrene does. A long time ago, I mean, I don't do jewelry work, but a long time ago, I did some gold and some silver chairs for Len Newman of C&L Track Work. and we made those into charms for charm bracelets and necklaces and earrings and stuff. And they went very, very quickly. I think some model railway enthusiasts thought they might be able to appease their wives and loved ones with railway based giftware, but he supplied those chairs. Instead of supplying them to me in the material that they use, the ABS that is used for those chairs these days, well, from that time, I said, do them in styrene and they'll cast beautifully. And sure enough, did them in styrene, no problem, cast beautifully. When they were in the ABS, the reject rate was quite high. It doesn't burn out as cleanly. So that's just something to note. And when we were developing, I was helping out with the development of wheel centers for the 2mm scale. Their wheels used to be white metal centers cast into rims like Slater's ultra scale, where they had a groove on the inside of the rim. They used to cast the white metal into the centers. When the chap who did that, I'm not sure if he died, I can't remember, they decided they wanted to try brass centers. And Mick Simpson of the 2mm Association, he came to visit me, and we chatted and we tried various different ways of making molds, rubber molds, to do the waxes. But the distortion, you only need a very slight distortion, and it's too much for 2mm scale. And I said they should be injection molded. And I supplied him with a little benchtop injection molding machine. He went away, made some injection tools, did the plastics, cast them, worked perfectly. And that was the start of 2mm wheel centers in brass via Mick Simpson. And it was just a bit of development, just trying different processes until eventually we found that works. Now, in 7mm, I can do a wheel center. In fact, I've got it. This is an M7 chassis. And if my mate Bob Langford is watching this, he'll be horrified. It stood on my shelf for ages, but he assembled this for me. These wheel centers here, they're all brass. And they were originally injection molded plastic. And we turned them into brass, and they're rim insulated wheels. These days, of course, you could use a 3D print. People have been using 3D print, but we cast it. It has a square hole that can go onto a Slater's or Walsall Model Industry style axle, and they're beautiful and they're very fine, which allows you to get the rim is much finer than some of the plastic centered wheels that we've seen. I couldn't make it viable, which is a shame, but it does work. And injection molding was the way to go for that kind of thing. Right, sorry, I'm plugging myself, and I didn't mean to do that. I apologize for that. Slightly up, some plastics don't burn out. 3D printing. There we go. 3D printing is the buzzword of the moment. That's what I've written down here. And it's a great way to make patterns for lost wax castings. Now, I've been involved with this using 3D printing, rapid prototyping for years, and just watched it start off slowly, and the improvements were just very, very slow. And then suddenly it's just gone through the roof, and the quality of the prints that we see these days is out of this world. And 3D prints can be used for masters. But I wanted to touch on some of the aspects of them for lost wax casting here. There are various different processes that are used for 3D printing, and I want to just touch on the ones that most of us will have access to, which would be the machines that are like the Elegoo, Mars, Saturn, etc., and the Frozen Mini and the Frozen Mighty. These are cheap machines to purchase. Once you've learned how to use them, the quality is fantastic. Okay. But I wanted to touch on the experiences that I've had of 3D prints that have come to me, and 3D prints that I've had myself made and made, and what sometimes happens with the molds. Now, of course, once they're cleaned up, once the support structures have been removed, they can be used for masters. What I find is that the print material, sometimes you can't see the builds, and it's worth just doing a light coat of primer, and then the builds, where there are any, will stand out, so you can clean those up before that pattern comes to the likes of me to make a mold and to do a casting of. But also, sometimes, even though the print has been through the isopropanol and has been through the ultraviolet light curing station for its allotted time, the mold rubber doesn't always cure against it, particularly little nooks and crannies, and it will stay soft and sticky. Now, I know this from my own experience, from one of my own kits. We did a backhead, and eventually it was the third. Even though I coated it with primer the second time, it still didn't set properly. Some of the curing stations come with an ultraviolet light pen, a little pen. It's worth going around some of those nooks and crannies and any holes and just doing an extra bit of cure before you send it off to have a mold made. Otherwise, the molds don't always cure. The other thing is, what I've found is with 3D prints, these 3D prints that are cured with the ultraviolet, is if you drill a hole into it, so it's almost like a case hardening. If you drill a hole into it, any rubber from a mold that goes into that hole, generally speaking, will not cure properly. So again, the little ultraviolet pen into that hole to get some extra curing on inside of that 3D printed resin master is worth doing. Okay, now these are just experiences I've had, and I've done a big search on this, and I only found one chap who online who was talking about the experiments that he'd done to try and get around it, and it was very long-winded, and it still wasn't guaranteed. So some of the processes work brilliantly, some of them just need a little bit extra time and care in the curing and finishing of. Don't forget also that the silicone mold will show every detail and blemish on the printed pattern. Even the fingerprints will show, and they can show on the finished casting. So again, I know I keep on mentioning a light blow over with a primer, but any builds and defects show on primer, and allows you to wet and dry and clean up before you send it to get the casting done. Then you will find you'll get much better castings. Now, it sounds like I'm preaching here, but learning the idiosyncrasies of your machine and the materials that you use on the machine is key to the quality of the finished print. The publicity suggests that these machines are plug and play. Well, they kind of are plug and play, but they're kind of not plug and play. What you will find is that the more time you spend, use the forums, etc., you can learn more, so that your prints will actually come out better. But it's a learning curve, and it's a learning curve by picking the brains of others. So just remember that you get the machine, you can plug it in, and sure enough, it'll print a wagon or whatever. But if you get it at just the right angle, etc., you'll find that the details are just that much sharper. So that's just a bit of preaching, and I think that is about as much as I can share with you, unless you've got questions. And I noticed someone mentioned the issue of the MRJ. Was it issue 19? By an article by Mike Cowley in the MRJ number 19 on lost wax. So it's an interesting one to track down. If you haven't got it, borrow it off somebody else. But it's worth having a wee read of that. So if anybody's got any questions or they want anything more to know, feel free to talk to me at shows. I'm more than happy to rabbit on about the subject. I do get quite animated, and I'm a bit of a lost wax bore. So I'm sorry if anything that I've talked about has bored you. Hopefully,
No.
And hopefully you've learned a little bit. And if you want to learn a bit more, chat to me. If you're ever in the area, give me a shout, and you might be able to come and see some of that process in action in my workshop. Obviously, I can't have people in groups, but you know, if you come on one of those Settle in Carlisle train journeys, and you've got to spend 2 hours in Carlisle, then give me a shout, and you can have a wander around and come and see aspects of the process and see just how messy my workshop gets.
It does get messy.
Oh, it does very much so.
Just before we move on to opening the forum for questions, Ian McCormack, would you like to unmute yourself and pose your question to Ian? So this is the Ian triumvirate here, I suppose.
Of course.
Right, I was just wondering, you know, I've got an Elegoo Mars and Saturn sat next to me here and stuff. Do you actually? Machines. Yeah, brilliant. But do you print from the waxes that you can get, these castable waxes?
Yeah.
And what manufacturer would you use? Because there are several, and they've got different burnout cycles and stuff.
They have. Now, you know, I did have one. I did do a little bit of a search on those a while ago for a customer, and I've forgotten the name, but I think you can get it via Amazon. There's one or two of the burnout waxes, but they all burn out reasonably. Some of them burn out at a much higher temperature, and ideally you don't want to have to take the burnout higher than 750 degrees Celsius. That's just because everything else in there is going to be wax, and so I don't really like to take the temperature too much higher than that. But most of them you shouldn't have an issue with, particularly the ones that are manufactured specifically for those machines. But
I'm saying my daughter lives around the corner from you. So I think I've spoken to before COVID and stuff. But so if I printed some and actually brought them up, and you could have a look at them and sort of.
Well, yeah, I could look at them. The difficulty with the lost wax process is it's not a 1-day process. So
no, I understand. I've done some. I used to work at Chatham Dockyard making BAFTA awards.
Right.
As a summer holiday job at one time. Yeah. That was all open.
Yes, well, that would be what I call
what you were describing earlier
with risers.
Yes.
What have you made that? I mean, I'd love to do stuff like that, just for the experience of it. But it's so different.
Come a long way since those days.
Oh, it's fascinating though. There's some great videos on it. YouTube videos on doing that. It's great. You know, where you've got two men, you know, holding up the crucible and
with all the spats and all the rest of it.
All the
leather gear and stuff. Yeah, it's quite amazing.
It is fantastic. You see, you got me going.
Let's get back on subject. Right.
Sorry. Okay, I'll shut up. I'll mute. Thank you.
Okay.
Does that answer your question? Okay, Ian.
Yeah, brilliant.
Good.
No,
I mean, if you're in the area, bring them in, and we can take a look at what have you. And if you were going to be up for a couple of days, then we could probably put them in with some castings and see how they came out, because it would just be like, it's a 2-day process from that point of view, as long as I've got other things that are going to go into the kiln. So if you prime me beforehand, I'll prep a load of stuff so that we can have them, and we can bung them in, and then we could cast them, and you could be there when they're cast and quenched, and you could see how they came out. Okay.
Excellent. Right, brilliant. Yeah, I'll probably take you up on that, but I've got to get some of that wax stuff first. So,
well, that's the only other issue. These materials have shelf lives.
Yes.
unless you keep them dark and the cool and all the rest of it. And you're going to either be buying, half a kilo or a kilo or, 500 milliliters or whatever. And so you've got to weigh that up and the fact.
Yes. Yeah.
So it's
there's several things that require in Brighton Craven stuff is what I'm looking at. I think I showed you some stuff. Before the pandemic, a long time ago. I'm just getting back into doing it again. So we'll chat. Good, thank you.
Oh, I like a bit of Craven. I like a bit of Craven.
Yeah, I know. Yeah, you said that at the time. Brilliant.
Yeah.
Cheers.
Okay, no problem. Right then.
Okay.
Thank you,
Iain, question from Peter Callan. Why is it that on cast brass axle boxes, the holes to accommodate the top hat axle bearings are never wide or deep enough, and I have to waste time drilling them out?
Well, that will come down to the pattern maker.
There you go. Dead simple. Yeah.
Well, it is. In fact, hang on. Hey. All right, because I'm just going to talk about. I've got an axle box here. Now this has been vulcanized because I can tell by the tarnishing on it. This is an LMS Stanier axle box, but it is solid and has a pin on the back. You can't see it very clearly because it's dark.
Yeah, you can make it out.
Yeah. Okay. Ideally, I'd have that protrusion as a plug, and then then it would come out much nicer, but it would just then be a hollow casting. You'd have to rely on the frame to support the bearing if you were going to have an outside bearing on it. You wouldn't rely on this because that's too large a diameter for your standard for like a wagon type of axle. Okay, but the holes will generally speaking come out the same diameter, even though there's a shrinkage involved. For some reason, holes seem to come out the same diameter as when you start. So the pattern maker should have made the mold to suit either to put a bearing into it or to be the hole for the bearing itself. Sometimes they'll make it a bit smaller so you can have a nice. You can ream it or drill and ream to give a really nice finish inside, but it does essentially come down to the pattern maker, not the casting. All right, the shrinkage involved in the casting shouldn't affect it.
Thank you.
Does that answer the question? I hope so.
Yeah, I hope it does. I mean, I'd just like to say, obviously, from when I came up a few weeks ago to shoot the video, the preview video, I learned so much that day. I've said to Iain on the phone since when we chatting on Friday last week before we had a test session on Friday night, I said to him that, I hadn't even considered that the process was so different to the white metal casting that Andy Duncan does from Andy's session. And I say I just learned so much about how all the waxes go together onto the tree and how they go into the pot and get covered in plaster, and then the way it goes into the oven, and then gets the brass poured in afterwards. And it was a real eye opener for me just spending that day with Iain to see how he goes about the process of from the molds themselves all the way through to the finished product. So if any of you are able to spend some time in Carlisle and have time to pop in to see Iain, I suggest you do it, because it really is such an interesting subject, and I can understand why Iain gets so enthusiastic and passionate about it, because it is so engaging, just sitting there and watching the things happen, the processes that go into it.
Yeah, but in addition to that, it's about the only thing I'm any good at. All right, I'm pretty useless at everything else. So, I mean, I'm being bluntly honest. That is the case. So yeah, right. So,
are there any more questions before we start to wrap up this evening from anybody?
Hi, Iain. It's Mark. I know we've had a few chats at shows and things, but question, like, taking it a step back, you're obviously I know you're a passionate caster, and as you know, I've built quite a few of your kits and things. And I think the latest one, I've got one of your C14s on my bench
excellent.
I've waited to do, but not like the boiler on that's quite a big casting.
Yeah.
But how do you decide? Most people would make that an etch with overlays, or why do you decide to make that as a casting?
Right. Oh, here we go. I'll get just let me get in my soapbox. Right. I've mentioned the fact that I believe there's every media that we use in model railways has its place. Okay, and it was interesting because I had to be made to think about that. There's a chap who you see, he puts stuff on the forums quite regularly. He's a model builder. Quality is phenomenal. Uses a lot of 3D printed parts in the models that he builds. And he came to me at a stand, I think, to my stand at one of the shows. And we were chatting, and I said, "Oh, why don't you do more of those bits in metal?" And he said to me, he asked me a simple question. He said, "Why?" And I thought about that, and I didn't have an answer at the time. And I got diverted by a customer, and he obviously had to go back to the stand that he was on. But I spent a lot of time thinking about that. I'd be out on my bike or I'd be out walking to work. I thought, why? And I thought it was a very, very good question. In my case, because I can. But if somebody else was producing a kit, they probably couldn't do some of the things that I can get away with. So I can do that C14 with a cast boiler and a cast smoke box and all the cylinders and motion brackets and all the valve gear. Everything's lost wax. I can do that because it's my time, effectively, that I'm using. But if I had my commercial head on, the boiler would have been an etch that you'd have had to have rolled. The smoke box would have been the same, built up from etchings that you'd have had to form. I just wanted to make that kit. It was my little baby, and I wanted to make it as easy as I possibly could to build. And if you'd seen me when I assembled the valve gear on that loco, the first time I assembled it, it wouldn't go together because in being cocky, I thought, well, I'll just build it all off the model and I'll slap it on the model. What I didn't think about was the fact that some of those rods have to go through a motion bracket. And I had to take all the valve gate apart to put it all back together on the model. But the fact that it all went together and everything lined up, because we were able to do lost wax valve gear, where if it's got a right-handed fork on the linkage, it's got a right-handed fork on the casting, meant that everything just lined up and it just worked. And I, like a little boy, I almost danced a jig. But the reason I use a lot of lost wax is because I can. But I don't advise that for customers. I think there is a place for those 3D printed parts. And that question did make me think about more of all the different things that we use. There have been people in the past, those people who knew George, I want to say Pring, Kemmelway. The original Kemmelway chassis kits that they did for the Airfix models, he tried to etch everything because he didn't trust castings. And at the time, he was probably right not to trust castings, but he tried to etch everything. And you can't etch everything. Each of the different things that we use serves a purpose. Sometimes vacuum cast resin is a great thing for your saddle tanks or on models. White metal has its place. Some parts aren't FEMA. I usually say, if you're going to have brass in your kit, start with the FEMA bits and work from there, because by the time you've got to the end, some of those bits could be 3D printed resin, could be resin poured, could be white metal, and don't need to be in brass. But every medium has its place and its purpose. The C14 was my choice to do that, and I enjoy building it. So hopefully.
When I finish what's on the bench, it'll be the next one.
Good. Well, I hope you enjoy it. I actually enjoyed building it when I did the instructions. What you see in the instructions is my builds, wart and all.
Okay.
Wart and all
There's certainly a lot of photographs on the memory stick.
Yeah, but that's the joy of digital. Again, that's the medium. You think back to when, if I went to go and research a locomotive or whatever that I was going to produce a kit of, with an old, and Iain Allen obviously can back this up. you're taking a camera, whether it be your Instamatic 126 or your fancy Nikon F1 or Nikon F with a 35mm roll of film in there, you had to make sure all your light and everything was. You weren't sure how good those pictures were going to come out until you know, a week later when it came back from the chemist. Now you can photograph things with a digital camera and you can take as many as you like from any angle. And what a boon that is when it comes to writing instructions. You know, it saves you writing loads of long-winded bits because you can photograph every single part. And it just makes life, hopefully it makes life easier for the
It's better than an isometric drawing, isn't it? Where you can't actually see the
I can't do isometric. You've seen the quality of my sketches. You can imagine what I'd be like if I was trying to put isometric in a kit. I'm sorry.
That's why you do brass casting, isn't it?
That's why I do brass
casting.
Yeah, that's exactly right. Yeah, so yeah. Right. Hopefully that answers
no, thanks, Ian.
Yeah, no problem.
Tim Stubbs says, I used to live in Carlisle. Wish I'd known.
Yeah, well, I've lived here. I mean, I'm from Sunderland originally, but I've lived here for 40 years. Yeah. It's an all right place. Once the Cumbrians accept you after 35, 40 years, then you know, you don't want to move back to a big city. You know, Carlisle's got that small town feel, which I like. It's a nice place, but it is out in the middle of nowhere. Every exhibition is a long way. I mean, I'll be coming down to Guildford, weather permitting, and that's a long journey. Guildford's my favourite show, so I will be there. If you know, unless it's absolutely, I can't get over Shap. If I can't get over Shap, then he won't see me. All right. Anything more? I'm happy to answer anything.
Another Ian Haynes. What are the smallest dimensions you can cast? Now, before you answer that, I've got an idea because you showed me some exquisite 2mm scale castings that you've done a while ago. So, over to you.
Okay. It's difficult to give dimensions because when you, again, going back to 3D printing, they will tell you the minimum size or the maximum size of the pixel that they can print at. And so you can have surface detail that could be really, really fine, and it'll cast no problem, you know, and it'll show lettering on axle boxes and that kind of stuff. All of that kind of stuff will print. But then you start thinking, okay, let's take well, here we go. Another pattern. Matching pattern for the axle box is the spring and hangers, Stanier ones. And so you've got your spring and your hangers there. And I mean, they're quite thick, they're quite heavy. We could go much thinner than that. But of course, the length might make a difference to what we can get away with. But as Ian says, 2mm scale. I did some castings. The first locomotive I did the 2mm castings for were for a northeastern. So we'll call it an LNER because I know it was a J72. And he brought the smoke box, the chimney, the dome, the safety valve. And he said, now look, in the bottom of the bag, there's a couple of pieces that look like swarf. He said, they're the chimneys. All right. It's in 2mm scale. And sure enough, when you take them out, they, you know, if you look at them under an eyeglass, he had got the two northeastern chimneys. So one's like an organ pipe chimney and one's a traditional, sorry, not chimney, whistle. And one was a traditional, what you call a traditional shape whistle. But he got the shapes beautiful. And they all cast without any issue. I usually say to people, let me know what you want to produce, and I'll let you know what I can do with regard to that. But we can take it down. I've taken holes down to 0.3, but that's really through a surface. It wouldn't be through. You wouldn't have a long. You couldn't have a long hole of 0.3. 0.45. You can get away with a lot more. 0.7. Well, you can get away with loads with 0.7. And then 0.9. I'm going by the wires that I have in the workshop. 0.9. Then almost the sky's the limit. What you can get away with. But with regard to surface detail, almost anything. A thumbprint will show. If the thumbprint shows in the mold, it potentially can show on your casting.
Yeah, yeah. Alex Dent says Carlisle is my favourite city in Cumbria. Besides, Cumbria is where he was born. Tim Stubbs then says, I always thought of Carlisle as a big village.
Well, it is really.
And then he does actually ask a pertinent question. Roughly what proportion of your work is 7mm, and do you do larger scales?
Right. Okay. I did cast a couple of handles for a locomotive that chugs around on the Festiniog, but I tend not to do that size of stuff. If you were getting into that size, into really big stuff like that, you'd be using a company called Devon Metal Crafts. Really nice guys. Although they do some model railway stuff, they do specialize in furniture restoration and film props. But they're a great company. Really nice chaps. Quality's good. The majority of my stuff is 7mm. I think that's probably because I'm in the 7mm market myself. But I do I've done quite a lot of 2mm stuff. And I won't mention company names. I do a fair amount of 4mm. The odd bit in 3mm, 3.5. I've done some S-scale stuff in the past. And then gauge 1, I do a bit of gauge 1, and I've done some 16mm stuff. But I tend to draw the line at that point. 16mm, again, I would probably be passing those kind of customers on to Devon Metal Crafts. I would suggest they would use Devon Metal Crafts, just because they're tooled up for the bigger bits like that. I used to do live steam fittings for a chap in forgotten place, but in the south of England anyway. And I did gunmetal cylinders for his locos and did his chimneys and domes. These were all 16mm bits, but they take up a lot of space in the molds, in the casting cans. And I just think it's better to use someone who's tooled up for doing bigger bits. For those, and Steve Lendon, who was one of the partners at Devon Metal Crafts, I think he's either retired or semi-retired. We used to have a great relationship, and I would often, if someone brought big furniture restoration bits to me, I would often pass them on to Devon, and they would sometimes pass model railway or model people on to me. So we had a lovely relationship that we could just phone each other and chat, and that's always a boon to have someone else that you can bounce off in that respect. So Devon Metal Crafts for the 16mm and above. I have done wheels for things like gauge 3 and etc., but I tend to avoid them where possible. I mean, I've got an oddball thing here. Some of you might recognise what this is.
Yes.
Yeah, this is for the Rolls-Royce Owners Club, and I'll be doing those. I'm doing some of those, and they're going to go off to be nickel plated, and for the club, and they'll be using them for whatever. But generally speaking, most of the stuff that I do is 7mm scale, British and continental. I do some 3.5. I've done some HO stuff for Sweden and Norway as well. I like the challenges. So, I have one customer who challenges me every time he does a new loco. And he pushes the boundaries of what I can do, and I've learned a lot as a result of customers who've done that. So always feel free to question me when you're producing a pattern. Recently, someone gave me a pattern to do. They'd done a 3D print. It was an injector for an LNER loco, and I did it for him, cast it for him. He seemed happy, but I showed him the exhaust steam injector that I used for my Lord Nelson kit when I did the Lord Nelson, and he could have assembled more of his pattern when he printed it rather than doing it as sub-assemblies, but he didn't know what I could do for him. So he learned from the casting that I sent him of the Nelson exhaust steam injector along with his casting. He learned hopefully from that he can actually push a bit further and do a bit more. So does that answer the question? Hopefully it does.
Yeah, Ian, following on from Ian Haynes' question about what is the smallest diameter that you could cast, I'm thinking of an example of let's imagine a grill that consists of, you know, sort of in real life vertical metal bars. If you were to do that in, well, even in 7 mil, but in 4 mil scale, these would be very, very fine. Is there a limit of the diameter that the metal, the brass, will flow through? I mean, could you will the brass flow through a very, very small diameter?
Yes, the simple answer is yes. I've always said if I can produce a wax, I can produce a casting. Okay, that's the limitations of what I've got. Now, of course, because people can 3D print very fine items, it's possible that I might find a limitation. If you want to see some things that have been, or that are cast very, very fine, you can check out a German company called Indutherm. It's Indutherm, Indutherm in Germany, and just go through their website. They manufacture the casting machines that I use. Okay, but they've done very fine. They've shown very fine mesh that they've cast, and that. But I've not done. You're dealing with much higher temperatures then to get the metal to flow. Not so much the temperature of the metal, but the temperature of the flask to get to keep the metal from chilling before it's filled every nook and cranny. But in theory, the metal should fill all of the mesh. But it's worth checking out Indutherm. It's a fascinating site, and you can see my machine more in action because they've got their own little bits of video showing the process, and they are very clever blokes. They really are the chaps who developed the vacuum assisted gravity casting process, which most manufacturers of these machines around the world have copied, refined in their own little ways, but effectively they are the big boys when it comes to those machines, and they are lovely. They're a joy just to open and just look at the wiring, and typical Teutonic, everything's just perfect inside. But still, that's but yes, the answer is yes, you can do it in theory, but again, how many shots do you have to have a go at before you get it to work? And I do have things where I have to cast them a couple of times before I'll get them all to cast. It's just the temperatures that affect them, really.
Thanks, Ian.
Cool. Just going leading on from that, I've just put the web link in for Indutherm in the chat box, and also kind of pertinent to what Dave's just asked and what we were chatting about earlier. John Walker has asked, on minimum thickness, do you expect problems with metal flow through scale spokes like your M7 wheel?
Right. Now then. I received I've got to say that I should have brought the mold with me, but I didn't. It's nice to show off some of the things that you do, but you don't want to give away everything. Okay. And I received a mold pattern once that had been through the hands of 2 casters before it came to me. One of which no longer exists, but it was for a Great Western H spoke wheel. Now the H spoke was obviously done as a T-spoke because you wouldn't be able to get the rubber out if it was made as a proper H spoke. So it was done as a T-spoke, and then there's a plate put on the back to create the H spoke in the wheel. The pattern came to me. It was made by a very famous locomotive builder who was recently passed on, and I got a casting with it, which had been cast at one of these shops and one had been cast at the other shop, and in effect they had just sprued it wrongly. That's all. The way the mold was made meant that you were always going to have an issue, because in the center of a driving wheel you have a boss, a crank, which has mass to it, and you're expecting the metal to flow through what effectively is plate work to fill that mass in the middle. And even with spokes, it's going through thinner spokes to fill that mass in the middle. And what happens is you end up with porosity or deformity in the center of the wheel. So one has to feed appropriately to get that to work. So you really want the feed to go to the boss as opposed to the rim. And it's just but making a mold to do that isn't always that easy. So it's but I guess it can be done. It's not a huge issue, but yeah, it can be done. So there's no worries in that respect. But I would probably, when people often ask me about where do I put the feeds on the patterns, and I meant to make notes on that, and I'm sorry. I usually tell people to send the pattern to me and I'll put the feeds on. I use what's called sticky wax. So there's no heat. Well, there's a to attach the feeds to the patterns. So I usually like to feed to sprue things up to suit me. And because 99.9% of my castings are for model manufacturers or model makers, and I'm a model maker and a model builder myself, I tend to think like a modeler. So I'll try and put the feeds where they are the easiest to clean up for the modeler. If they go to, and now I am decrying jewelry casters a little bit, if it goes to a jewelry caster, they're going to bung the feed where they want the feed, okay, because they'll to get what they will think will be the better casting for them, and they won't always put the feed where would be more useful for the modeler. But they're jewelry casters, and you've got to be fair to jewelry casters. They will think like a jewelry caster. That makes sense. Someone came to me and said, "Well, you do some, gold rings." I'll say, I'll give them a name of a jewelry caster down in Birmingham. I said, they'll do a better job than me. Why use me for that? So, they know their stuff in their area, and I know my stuff in my area. But I usually ask, sometimes if they haven't made the pattern or in the process of making the pattern, I might say, well, can you just extend that a little bit? That way I can attach the sticky wax to that rather than attaching it to some protrusions from the from the master. But otherwise, I like to sprue them up. I like to think that I'm thinking on behalf of my customer. I mean, those early molds that I showed you where it had, one chimney in a mold, I wouldn't dream of doing that now. But that was when I started, and all I knew was what I was being shown from a jewelry caster. I would never dream of doing that. There's some river castings again. I'm sorry, these are new river castings, but they're the springs, and we've got holes through here for the hangers. The original river, the hangers were part of the spring, but from the point of view of painting, etc., it's much nicer if you can take everything off and put them back on. So I changed them, and they've got holes in. But that's a sprue, so we have more than a chimney. We have a few other items in a similar size space. So that's what I would do. But I'm being paid again. This is for M7 push pull equipment. I'm paid to be able to cast those little fine bits in a manner that the modeler can make use of. So, for example, this shaped plate piece here, the feed goes hopefully right to the lip, so that you've got the minimum amount of metal to clean up, to put on your model. Whereas it would have been much easier just to slap a big old lump onto the back, and then it would have been taking you much longer to clean up. So, and my brass does not forgive blunt tools. Okay, I'm just letting you know. It's a low zinc, no lead, high copper content brass that I use. And if your tools are blunt, it will bite you. Okay, it's fabulous because you can bend something, and then you can bend it back. You know, it's very forgiving from that point of view, and the fact that the parts don't break as readily as some other brasses. The alloys that I've chosen to use, I think, are the best ones for modeling purposes. The dome, for example, when you polish that, it will come at that will come up around about an 18-karat gold color when it's polished, and on the model it'll look the right color. The copper chimney, which is actually phosphor bronze, 95% copper, 5% tin, when that's burnished on the top, it'll look the right color on the model. I always remember the Triang Hornby, the 9F, when the 9F came out, and they did the Evening Star, and it had the copper chimney was pure copper, and the color looked wrong to my eyes. It looked wrong. And the phosphor bronze on the model looks right. So, you know, it's a perspective thing. But that's just something that, because you're looking at metal all the time, you become a bit anal about it. Oh, I have anyway. Sorry.
Yeah.
Okay.
No, that's fine, Ian. I think final question for tonight, looking at the time. Tim Stubbs, can you say how many locos you have built for your own personal collection?
Oh, crumbs. I can tell you how many half-built ones I've got, which is a phenomenal number. I don't consider myself a particularly good... I consider myself an average modeler. So when I do a kit, or when I revamp a kit that I might have taken over, I'm busy doing I'm doing the instructions for a Kirtley well tank that was originally designed by Rod Neep, and just doing some mods. And I work on the premise if I can build it, then I know my customers can build it. I'm only an average modeler. I look on in awe at some of the stuff that I see by various well-known names online and at shows, and I think, oh, how do they do that? How do they wield that sort of such? You know, I am in awe of them. But I just consider myself a run-of-the-mill modeler, and I've just been building models for a long time. The very first 4mm loco I ever finished was an Alan Gibson 3P. Looks like a 2P with the square splashes.
At
the front of the cab, and that and Fleetwood Shaw took that off me and used to run it on his layout because I built it to EM. The first 7mm loco I ever finished was another Alan Gibson 2P, and I remember I hated the cab, and it just had if you don't get that pencil roll either side of the cab right, the cab roof will slope. And mine had this slight slope. My eyes would just go to that slight slope every time, and it drove me nuts. I eventually sold it to someone. I said, no, it's got a slight. He said, no, I can't. No, he was happy. He was over the moon. But I did point it out to him, but I couldn't live with it. I've built a fair few over the years. I've got so many half-built ones, because you end up building a model for the instructions, and quite often you don't finish it, you don't paint it or whatever. So I don't know the number I've built. But you know, every kit you learn something new. But I am much more in awe of a lot of the other chaps out there. I'm run of the mill. I really am. Some wouldn't touch what I Others think it looks lovely, you know. So yeah, and again, you never stop learning. No, I don't know how many I've built. I really don't. Some of you chaps will have built bucket loads more than me, you know. But yeah, I'd like to be able to build coaches, because you know, you don't see that many hand-built coaches, and I think the knack for building coaches is different from the knack from building locomotives. That's me waffling. I'm sorry. Yeah, right.
Now, Tony Andrews actually builds some very nice coaches, would probably say the same thing, and he sent asked me to say something to you, and I can't remember what it was. Anyway, there you
go. Just while I've got an audience,
yeah,
someone came to me at the show and brought me an anchor, a 3D printed anchor to cast for him, but I didn't take his details. And I've done the castings. I've got the castings. So if anyone out there knows someone who had 3D printed anchor done, I've cast them. I've got the brass castings for him, whoever he is.
Was he a guild member?
Possibly.
Because we can always put a post on the forum.
Well, it might be worth doing that. I feel embarrassed. They're sitting on my bench, and every time I look at them, I go, "Oh, you pillar," you know. Yeah. So it's just one of those things that I don't think I took his details, and now I feel bad because I've had them. I did them as soon as I came back from the show. So you know, these things do happen. Right.
They'll remember. Right. If that's it from everybody, I'm just going to do a quick wrap up. So I'll take the spotlight off Iain.
My goodness. Oh dear.
Yeah, and I'm going to do a screen share. Oops, I think I need to press that. I need to do screen share. So basically, thank you, Iain.
You're welcome.
For our final session of the year. Hope you can all see this. This is what we've got currently booked for 2024, an evening with. Starting in January, Neil Armitage is going to do a session on weathering one of Ellis Clark's new Black 5s, which customers should be receiving, I think, this coming week. The first customers and the first batches. February, Nick Dunhill is going to do a session on metalworking. Members from the guild have asked about if he could do a session on basic cutting metal, straight lines in metal, using piercing saws and things like that. In March, Will Heath from St. Neots Club will be doing a session on making buildings from card. Will is probably better known amongst Slodderower fraternity as the guy that built the 2 mil fine scale model railway of Swindon that is still on the exhibition circuit. And all the buildings from that he made from card. April, Rob Pullum of the Guild will be doing a session on working with lathes and how lathes can help you in your model making. And I think he's going to also touch on milling machines as well, for anybody that wants to know about milling machines or lathes. Peter Reynolds will be doing a session on DCC servo control in May. So anybody that's going into DCC or treading their feet gently into the DCC world and has looked at servos, Peter's session will be pertinent to that. And in June, Rennie Lord from Pontefract and Normanton Club, probably with a couple of other of their members, will be doing a session on the Selby layout, which obviously a lot of the guild members know about from the late Tony Kell, who was involved with that, who did some very nice work on the swing bridge at Selby that they all went out and measured and have made for their new layout. July through November next year, we're still awaiting confirmation on a couple of people that we've approached to do some sessions. So we haven't put anything in for the latter 5 sessions for next year, specifically because we're just waiting for some confirmation from certain people. Anybody that's not a guild member, and I think everyone that's with us tonight is guild member. If you're not a member, join now. Introductory offer, etc., etc. The usual blurb that we get. So if you're not a member or know somebody that's not a member, they can get free membership for a month, and then obviously they can join at the end of the month period for a year. The membership is now rolling, so whenever you join the guild, that's when your membership starts from. I'm going to stop sharing that now because I think we're all pretty au fait with that. I'd just like to thank Iain again for this session this evening. I know he was rather I'm not so reluctant, but a bit concerned about how this would go. But it's 2 hours, and it's been really, really interesting. I mean, going from the basics of where you got into it and going through all the different processes. I'm sure that everyone saw the video that I shot showing the processes from the start through to the finish. So I think it's been a really interesting session for everyone tonight, Iain, and thank you again for your time and your input to this session.
You're more than welcome.
Thanks, Iain.
Okay.
Cheers, Iain.
All right. Bye, folks. Bye.